Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel. So in my previous video, I had explained about example 1, 2, 3, 4, and 5, which is there in this particular chapter. So now in this particular video, I'll be starting the exercise questions. So I'll be solving the exercise questions in exercise 8.1. So in exercise 8.1, we'll look into the first question. So in this particular first question, they have given that if the diagonals of a parallelogram are equal, then show that it is a rectangle. So that is, if we consider a parallelogram, where AB is parallel to CD. So I am considering ABCD as a parallelogram. So here AB will be parallel to CD and AD will be parallel to BC. So in this particular parallelogram, if you draw diagonals and if these diagonals are equal to each other, that is if AC is equal to BD, then this particular parallelogram is a rectangle. This is what you need to prove in this particular first question. So now here let us consider A, B, C, D as a parallelogram. Here, since ABCD is parallelogram, AB will be, so therefore here AB will be parallel to CD and AD will be parallel to BC. And one more data they have given, diagonals are equal in this particular parallelogram. That is and here they have given AC is equal to BD. This is already given in the question. So now we will consider these two triangles, that is ADC and DBC. So now here I'll consider two triangles. So consider triangle ADC, that is this particular triangle ADC I am considering, and this particular triangle, this is ADC triangle and this is BDC triangle. Consider ADC and triangle BDC. So in these two triangles, AC is equal to BD. They have already given this. So AC is equal to BD. This is already given. And we know opposite sides of a particular parallelogram are equal to each other. So AD is equal to BC because of theorem 8.2. So in theorem 8.2, we had discussed that opposite sides of a parallelogram will be equal to each other. And here DC is equal to DC, that is anyway common side. So this is common side. According to SSS postulate or according to SSS theorem, so according to SSS theorem, here according to this particular theorem, here triangle ADC is congruent with triangle BDC. So since these two triangles are equal, this angle will be equal to this particular angle. Therefore, angle D will be equal to angle C. So now we have got angle D is equal to angle C. Now we will consider these two triangles, that is this particular triangle ADC and this particular triangle which is ACB. So these two triangles we are considering. So when we consider these two triangles, so now consider triangle ADC and triangle ABC. So now we will prove these two triangles are congruent with each other. So here AD will be equal to BC. So AD is equal to BC. This is because of theorem 8.2, where it states that opposite sides of a parallelogram are equal to each other. Theorem 8.2. And here AC is equal to AC because AC acts as common side. So here DC is equal to AB. This is also because of theorem 8.2. So now again according to SSS theorem, therefore according to SSS theorem, here according to SSS theorem, triangle ADC is congruent with triangle ABC. So that means here angle D will be equal to, therefore angle D is equal to angle B. This is because triangle ADC is congruent with triangle ABC. So now we will call the previous one, that is here D is equal to C, as equation 1. We will call this as D is equal to, then we will call this D is equal to B as equation 2. So now according to equation 1 we have D is equal to C, and according to equation 2 we have D is equal to B. So therefore D is equal to B is equal to C. So now angle A plus angle B plus angle C plus angle D is equal to 360 degree. This is sum of interior angles of a quadrilateral is always equal to 360 degree. So in bracket you can write sum of interior angles of the quadrilateral is equal to 360 degree. That statement you have to write here in the bracket. So now we will consider these two triangles, that is this particular triangle and this particular triangle. So these two triangles will consider. This is ADC and this is ADB. So we'll consider triangle ADC and triangle ADB. So in this triangle you can see AC is equal to DB. We have that because AC is equal to BD. This is because they have already given this. Diagonals of parallelogram are equal. They have already given in the question. So AC is equal to BD. And here DC will be equal to AB. So here DC will be equal to AB. This is because of theorem 8.2. This is because of theorem 8.2. And here AD is equal to AD because they both act as common side. So now according to SSS theorem, so therefore according to SSS theorem, here triangle ADC is congruent with triangle ADB. So that means this particular angle D, this particular angle A will be equal. So therefore angle D will be equal to angle A. This is because triangle ADC is congruent with triangle ADB. So now we'll call this as equation 3. So now from equation 1 we had got D is equal to C. From equation 2 we have got D is equal to B. And from equation 3 we have got D is equal to A. So now A plus B plus C plus D is equal to 360 degree. So now all these angles are equal to each other. So I can just write A plus A plus A plus A. So in the place of B I am writing A, in the place of C I am writing A, in the place of D I am writing A. Because here D is equal to C, D is equal to B, D is also equal to A. So A will be equal to B will be equal to C is equal to D. So therefore I am writing A plus A plus A plus A is equal to 360 degree. So that is 4 times A is equal to 360 degree. So therefore angle A is equal to 360 degree divided by 4, that is equal to 90 degree. ABCD is a rectangle. So now we'll move into the second question in this particular exercise 8.1. Here they have given show that diagonals of a square are equal and bisect each other at right angles. So here we have to consider a square. So we have to consider a square and you have to prove that diagonals in a square are equal and they bisect each other at right angles. So you have to prove so many things in this particular question. So let us consider ABCD as a square and we'll connect AC and we'll also connect DB. So you have to prove one of this angle is equal to 90 degree, and you have to prove that these two diagonals are equal to each other. So now we will consider, so now we will consider square ABCD. Let us consider, so here let us consider triangle ADC and triangle BDC. So that is, we are considering this particular diagonal ADC, and we are considering this. So here we are considering this particular triangle ADC, this particular triangle BCD or BDC. So in these two triangles, here AD is equal to BC because all the sides in the square are equal to each other. So here AD is equal to BC because ABCD is a square. Since ABCD is a square, opposites, all the sides will be equal to each other. So AD is equal to BC. And here we'll consider this particular angle and this particular angle, that is ADC and BCD. So ADC is equal to BCD is equal to 90 degree. Again, here also you can give the same reason because ABCD is a square. Because in ABC, even in a square, all the angles will be equal to 90 degrees. So this particular D angle and this particular C angle both will be equal to 90 degree. And because both of them are equal to 90 degree, ADC is equal to BCD. Now we'll consider this side, that is DC. So DC will be equal to DC because DC act as common side. So DC act as common side for both the triangles. So according to SAS theorem, so here, or according to SAS axiom. So according to SAS axiom, here triangle ADC is congruent with the triangle BDC. So therefore here this particular side will be equal to this particular side, that is AC will be equal to DB. So therefore AC is equal to DB. This is because triangle ADC is congruent with triangle BDC. So now we have proved diagonals of a square are equal to each other. So therefore diagonals are equal. So one thing we have proved, that is diagonals are equal. So now you have to prove that they bisect each other. So that means you have to prove that this particular line and this particular line. So if we call this point as O, then OD should be equal to OB. If we prove that, and we need to prove that this particular side is also equal to this particular side, that is AO is equal to OC, and we should prove OD is equal to OB. So now we will consider these two triangles. So one is AOD, the other is BOC. So consider triangle AOD and triangle BOC. So here AD is equal to BC because ABCD is a square. So in square, opposite sides are equal to each other. So ABCD is a square. So now AD is equal to BC, and here AOD is equal to BOC. That is because they are vertically opposite angles. So these two, because here DB is a straight line, AC is a straight line. So AOD and BOC act as vertically opposite angles, and that vertically opposite angles will be equal to each other. So vertically opposite angles. Now we will consider this particular angle and this particular angle. So in the total diagram, if you see, here we have AD like this and we have BC like this. So AD is there and here BC is there, and here AC is connected. So in square, opposite sides are parallel to each other. So since ABCD is a square, so since ABCD is square, here AD is parallel to BC. So therefore here DAO angle will be equal to, so that is this particular angle. So here we have O point. So this particular DAO is equal to this particular ACB. So DAO is equal to ACB. This is because they act as alternating angles. Their alternating angles are equal. So AD is parallel to BC. So alternating angles will be equal. That is DAO is equal to ACB. So here we have considered one side, one angle, and one more angle. So that is according to AAS theorem. So according to AAS theorem, here triangle ADO is congruent with triangle BOC. So that means here OD will be equal to OB and AO will be equal to CO. So therefore OA is equal to OC and OB is equal to OD. This is because triangle ADO is congruent with triangle BOC. Since triangle ADO is congruent with triangle BOC, here OA is equal to OC, OB is equal to OD. So that means here, therefore, diagonals bisect each other. So that means here diagonals bisect each other because OA is equal to OC and OB is equal to OD. So now we have to prove they are perpendicular bisectors. So now we have to prove that they are perpendicular bisectors. So now in order to prove that these are perpendicular bisectors, we will consider this particular triangle, that is ADO, and this particular triangle, that is ABO. Here we will consider triangle ADO and triangle ABO. So here in these two triangles, AD is equal to AB because ABCD is a square. So this side will be equal to this side because it is the side of square. So ABCD is a square. So all sides in a square will be equal to each other. So AD is equal to AB. AO is equal to AO. This is common side for both the triangle. And here DO is equal to OB. This we have proved. This we have already proved in the previous case. So here according to SSS congruence. So according to SSS theorem. So here according to SSS theorem, triangle ADO is congruent with triangle ABO. Since these two triangles are congruent with each other, so here since these two triangles are congruent with each other, so this angle and this angle will be equal to each other. That is AOD will be equal to AOB. So AOD will be equal to AOB. This is because a triangle, this is because triangle ADO is congruent with triangle ABO. So we have proved these two triangles are congruent with each other. So AOD will be equal to AOB. So and we know that here DB is a diagonal, so it is a straight line. So here we know that DB is a straight line. Since DB is straight line, AOD plus AOB will be equal to 180 degree. This is because they are linear pairs. And we have proved that AOD is equal to AOB. That is, this particular angle is equal to this particular angle. So in the place of AOD, I'll write AOB. And in the place of AOB, I'll write AOB only. Is equal to 180 degree. So 2AOB is equal to 180 degree. So AOB is equal to 180 degree divided by 2, which is equal to 90 degree. Therefore, DB, so therefore this particular DB is perpendicular to AC. So therefore diagonals, so in the previous case we had proved that diagonals bisect each other. Now we are proving that DB is perpendicular to AC, that is diagonals are perpendicular to each other. So therefore diagonals are perpendicular bisectors. So diagonals are perpendicular bisectors in a square. So this is what they had asked to prove in this question, and we had proved that. So remaining questions which are there in this particular exercise, I will be teaching in my next videos. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.